Hi, David.
Sorry, I always lose Zoom and I don't know where the microphone is.
Yo, oh, Michael is muted.
Morning.
Yeah, let's not interrupt him. How are you, David?
Uh, Tired.
Why?
Um,
Oh, England. Exactly.
England. Oh, that was horrible.
no, I did. I like. I can't
I
watch.
watched it.
I can't watch England play. Like you get your hopes up, and then
Oh,
they just
yes.
disappoint. So the best way
You
to deal with it is to not watch it at all.
no, it was like it was a super good game, and England was dominating Argentina until they shot the goal. And then the English idea of the English players were, okay, we're ahead. Let's all just go back and stand in front of our goal and get these last 40 minutes over the
Yeah,
line.
Argentina scored like twice in the last 10 minutes, right?
It was insane. They were so good, the English. It was the best game, I would say, until they scored the goal of the World Cup of the English team. But yeah, anyway, it was like my wife was disappointed. Anyway, where's Poland? Did they take part in the World Cup?
Oh no.
Okay.
I mean, I
Poland are
don't.
too. Poland are so good. They're not allowed to compete, right?
Yes, they
Yeah,
there's a lot of regulation.
Germany also decided for early exit. Is that we managed the knockout stage. Let's go home now.
Switzerland got further than Germany, right?
Yes, but we get now a good coach with Klopp. So let's see.
Yeah.
Let's see next in 4 years. Okay, so let's talk about let's get the meeting started first. Uh, and let me share it quickly. Uh, Okay, let me all remind you that we all agree to the GraphQL Spec membership agreement, the participation guideline, the contribution guide, and the code of conduct. Also, please be advised that these meetings are recorded and published to YouTube, and we are using LLM to summarize these meetings. Let's do a quick round of introduction. My name is Michael. Pascal's not there, so come in.
My name is Camille from the guild.
David from Undergrad.
Okay, so I have put one. I actually am working on two larger pieces. I put interface object that is, I think, far enough spec on the agenda. You can have a look and I'll walk you through it. So I went through interface object. So I went through a couple of stages in looking at that. And I looked a lot at the issues people have with interface objects and how we could solve them without breaking backwards compatibility, or at least making backwards compatibility on this particular feature easy. Let me actually go in here. So one of the things is Apollo has a lot of runtime errors. Like they have certain errors that you could, with unresolvable keys, for instance, which they solve at runtime. And these could actually be solved at composition time. That is one thing I changed from the composition validation, just as a heads up. I think I posted somewhere on Slack that they actually, if you define, I don't know the actual thing, let me actually bring that in. Composite schema work group. There's, for instance, this example where you have a interface on subgraph A, and then on subgraph B you have a interface object which has a non-resolvable key. So you can actually not reach a review count. And this actually you could fail much earlier than at runtime, right? You could already add composition time, figure out that this is unreachable, and then fault this. And this is what I changed in the spec. Except if there is different opinions. I mean, David basically said they are doing similar things in window graph.
I haven't tested what Guild do,
Okay.
but I'm almost certain Guild would also be a satisfiability error here.
No.
It's not?
Camille, you are muted.
Oh, I don't know. I haven't tested it.
So you don't, because otherwise you would fail the compatibility test.
Makes sense.
Like the Apollo behavior is like if you want to emulate 100% Apollo behavior, you have to do that for Apollo Federation. This is one of the tests. That's how I looked basically at all the tests that we do for Apollo compatibility, and this is one of the test cases where you have to produce a runtime error. So, but I would.
But
Why
you know
would-
in advance that it's not resolvable, right? So it should be
Yeah.
a satisfiability error.
Yeah.
Oh, it's just a bug. I guess. Yeah.
it sounds I think I can't understand why we would ever want a runtime error over a pre-runtime error.
Yeah, so
Like
there's a yeah,
even if we're like even if you were trying to like mirror
yeah.
behavior, like this is behavior no one in their right mind would want to mirror, right?
So we have a switch in Fusion, which says you want Apollo compatibility, and then we also switch the setting off. Uh, Basically defer that to runtime. Um, but I think fundamentally, I disagree with having that in the runtime. So I want to, for the composite schemas, I do want to fail that at composition, except if there is like a big reason why you wouldn't want that in composition.
My feeling is that this is just an oversight and no one expected it to be a something that would only be caught at runtime.
Yeah, unfortunately,
Typically when runtime errors are uh, shown to the Apollo guys, they fix them so that they get caught earlier. So I would assume this is one of those cases.
yeah, I pinged them on that. Um, like when you there are cases even where um, they just discover that this is not resolvable and then they fail the whole plan. So they have one error. There's no data at all retrieved, and it's just a plan error at runtime. Okay, so in general, agreement on this. Okay. Upon GraphQL declaring the element. Yeah, so like this is a chain. This, by the way, also in the composite schema, we have like not a non-resolvable key. We have basically a key that has no lookup, but that is the counterpart of non-resolvable. One thing I introduced, by the way, is there is a group of issues that I clustered basically in 5 groups, and there are a lot of people asked for being able to override basically a thing that was provided by an interface object in a specific type. So I added one more thing to the interface object, which is called implement. And this allows you basically to say, okay, I have this interface object with text rate, but for the chair, I opt into implementing this field. So why an extra directive for this? Because it shows the intent that you really want to have a separate resolver for this field. Yeah, that needs to be shareable. Shareable if you had text rate somewhere else. Like if you have 2 implements, then you would need to have shareable on the same type.
But if it only exists in uh, on the field with the implement directive, and
Yeah,
then
that's
on
fine.
the interface object, um, you don't need like, is it then not coming from the interface object at all?
Yeah, so my assumption is this is not really an object. This is an interface. We just use the type here as a vehicle to.
No, what I mean is, so like how it works currently is that the directives get inherited to the
Yeah,
implementation types, right? So like schema B, if you kind of unfolded schema B, it would look
yeah.
like uh type chair and then ID and tax rate in schema B as well, right? So what I'm asking is tax rate also pushed into schema B as the interface object dictates, or because you've got the implement directive on another graph, does it then stop it from uh, being provided from the interface object?
1 second. So what you're saying is this guy here. So if we didn't have this guy, right, we would get
Hmm.
a we would get a schema, a composite schema that looks something like this.
Yeah.
Okay. And like if we have an implement here on tax rate, the composite schema actually doesn't change, right?
Right.
It's more like on this subgraph, I provide the resolver for tax rate on this type.
Um,
And implement is meant to signal that this is intentional, like you providing intentional a new functionality here because there's something different for this type.
correct. So my question is does so if you like so as we said, if we didn't have tax rate on chair in subgraph in schema A, it would then inherit it in schema B because of the interface object.
Yeah.
But if you do have it, does it not inherit at all from schema B? Or like does schema B like
Yeah,
when you unfold the schema B, like is if you imagine that these kind of like ghost types are then added in into the schema effectively in the like for the resolvers, is it as if it doesn't exist at all?
yeah, it's basically the planner would ignore.
So
Uh,
it would never be able to go to chair dot tax rate from schema B. It just doesn't exist there.
yeah,
Okay. Okay.
it basically is as if on schema B tax rate doesn't exist for chair,
Yeah,
right? We
okay.
would always resolve it here and not from there. But in the case of table now, we would again go here to get it from there.
Yeah, okay. Yeah.
And that gives you like this is interesting with requirements in their override rules, right? Where you could especially also change the type of tax rate. You could, for instance, change nullability, which is allowed in GraphQL, right? It's more concrete in the implementation type. So you can upgrade a type and raise the guarantee. Like, for instance, where it is interesting is like, let's say we have a nullable tax rate here, and then I can override it with a more with a required float here. So I guarantee for share you always will have a tax rate. Awesome. Let's go over it again. Content rejects text rate because it collides.
Silly
I have,
another
yeah,
silly question, if I may.
yeah, go ahead.
So in this graph, for example, you have the
Yeah.
interface, you have interface product and chair in the same graph. So at implement there, you know that at implement must correspond to the the. I mean, does the okay? I guess what I'm asking is, if there was another schema like schema C,
Mhm.
and then in schema C, chair it didn't have the interface, so there was no product interface. It was just chair. Would it still be able to have the app implement directive to say that it's overriding the interface object field, even though the interface isn't defined in that graph?
That's an interesting question. It
And
probably
and and
it probably
follow up
has to.
question.
Yes, it has to because it would because logically the thing will get this interface, and we with the implement we wanna um, avoid accidental overrides. Like if we had let's do it actually. Let's say we have that's actually the use case why I thought about implements in the first place, because if you have source schema B, C, and we actually don't have this guy, and then in C, we have chair. which actually now introduces a tax rate for whatever reason, right? And this is not. Then this could be an accidental contribution. It's similar to shareable, right? We want to contribute this field, but actually it was contributed already by the interface object, and that's where you actually need implement, because you want to signal this is a conscious decision to override this thing in this graph.
I think in Apollo GraphQL,
Mhm.
you can contribute an interface object field as long as you have shareable. Like it doesn't have to be a single source of truth. It has to be shareable, but I believe you can contribute it anywhere else if you want to.
You
I
cannot
think,
override concrete. Oh,
I think you can add a field and it won't blow up. It's just that it becomes shareable. So then, like, the query planner will pick whatever because they are identical.
oh
Yeah.
they allow this.
Yeah. Well, no, you would have to then add it on product in Schema B. You have to add it there as well. Yep.
Interesting. I have to try that with Apollo, because like what I researched was that this doesn't work.
Oh, but
Um,
it doesn't work.
I'm not going to put my. I'm
No,
not going
I'm
to
also
gamble
not.
anything
I'm
on it,
also
but
not. I'm unsure. Kamil, you
But
you
does not work, you mean like the composition error or the fact that it's just always skipped the field of, this particular type?
yeah. Would it so are text rate and text rate now interchangeable?
I mean, if they are shareable, then that's the contract, right?
Yeah, but this is like we are contributing here from an interface object. I thought you are not allowed to override them.
I'm not sure. I mean, if I remember correctly, but I would have to check it, is that like if you have an interface object and you add a field, and
Okay.
then this field is added to all the types that implement the interface, uh, and one of the uh, types that implement this interface have already that field, uh, I think it's just like no op, like it's just there. But it's not that, it will use that field always. Uh,
Yeah. Yeah. My intention was like you could always force it to go there, but I'm efficient to override the tax rate. It could be. It's a different effect, right?
I don't believe there's any constraints on uh, like what an interface object provides and what can be resolved elsewhere, as long as like shareable status is satisfied. I believe. Last time I looked at it.
Hmm. It's searching. I'm pulling out. And let me go back. Okay, that is interesting. Then we have to decide: do we want a follow the Apollo thingy to just be able to shareable, or do we want to give people a way to override that? This is more classical inheritance. Um, or do we want to have both? Could also be.
So silly again, another silly question perhaps, but
So I
what?
I'm not don't know how reliable Opus is, but it says yes, it's allowed.
So another silly question for me would be, what would the benefit be of constraining this? Because I don't what issue is the from allowing this?
From allowing the shareable here.
I mean, So you have an interface field which is contributing a field to a set of implementation types. Um, why is there a constraint that interface is the only thing that can contribute that type to those implementation types? Why can't those implementation types define that field elsewhere like any other shareable field? What's the what's the problem with allowing that?
That concrete implementation is provided or other interface objects.
So
So
the
so so
concrete
I
implementations.
yeah. I think there is no there is no problem in allowing other implementations to chip it in, right? Um, my thing was just, or the case that I tried to solve is that you have a more concrete implementation, right? You have a broad base implementation that is good for most cases, and then you want to override this function and say, like, for this specific type, I have a better algorithm for this. And
Um,
that's
I, so
typical in inheritance that you also have in Java or .NET, right?
so for me, um, that could still be something people would want, like to um, an implement override an interface object contributed field. Like I think, but that is also different to being able to define the
Yes,
same field elsewhere.
it's orthogonal, right?
Yeah.
It,
So
it
I think
solves
you can have a
different.
world where you want both of those things.
Yeah, yeah. Like, yeah. The shareable already solves that you don't accidentally override. I think the way I thought about it is that the shareable doesn't count in the way that because it's an interface, but yeah, it makes sense because it's also inherited into the object, and that's why you also can have a shareable contract between these two. Yeah, I think I'm gonna update this to include the Apollo Federation shareable semantics.
Oh, the shareable has like there's like two dimensions here. Let's say you have this like chair type across two subgraphs, right? And you want to
Mm-hmm.
also have a way to resolve that field that is contributed by interface object, right? Into
Mm-hmm.
subgraphs. So then you do need shareable, right? But
Yeah,
it doesn't mean that the shareable is like this field that is shareable is like semantically equal or like,
yeah,
with the one that is contributed by the interface object. So you have now shareable between subgraphs for that particular type. But since it's also like, contributed by the interface object, then, it's just like, so I feel like there's a space for shareable and there's also a space for this at implement where you explicitly say that like, hey, I do define that field. So if you ever want to like, resolve that field of that type, always use the origin, let's say, and not the thing that is like behind the scene adding that field.
yeah, yeah, exactly. I was thinking about that the traditional inheritance here. Whereas you're right. It's like there could be a world where you want to have this even you implement, and then you have two subgraphs where you implement. But this is basically overridden, so it doesn't need to be shareable because um, it's basically out. And then there is a world where you just want to say, okay, I have this, and these are interchangeable. David?
Yeah. So I've got 2 points here. First one is that indeed Apollo allows you to do this. I've just checked.
Yeah. Okay. I checked it with Opus, which is
No,
not.
I checked it for real. Um,
Okay, awesome.
and the second point, so in my opinion, you could have, well, again, maybe I'm being naive, but how is this problem not already solved by just being able to put at override there? Why not just allow at override to also allow you to override
Yeah,
interface object contributed fields?
override is different, right? You override something from a certain subgraph, or
Right, but here we're still the subgraph is just inferred because it's wherever the interface object is, right? But effectively, it's
Mhm.
doing the same thing.
I would have liked override more as a term because that's what you would use in traditional object-oriented languages. This would be nice, but to say I'm overriding it from a subgraph is strange. Because here you would say is override from B, right?
Right.
And then
But
here you,
what is fundamentally different between um
yeah, implement is like if you say the semantics of implement is I'm overriding a type member, an inherited type member, which we don't care where it is. It's like from a type system perspective. Like you're not even interested where this type lives. Where here you're interested in where tax rate lives, right?
mm, I think I'm still not following because in both of these you care where you care where the source of the thing you're overriding is in both cases.
What if you have, do you now override from both? Like for me, it doesn't matter where this lives. I just want to override its implementation that I inherited just.
Um, well, actually, first of all, I'm not sure. Uh,
I'm not sure if that
I'm
works.
not sure. I think you can do. I think you can just have the interface object contribute the same field in another graph. I think, but I'm not 100% sure. But I
Yeah, yeah,
understand I understand your point. Because you want to say like wherever it is,
yeah,
it's like a more powerful override, effectively, right?
yeah. It's on the type system. It's oriented at the type system. I'm overriding whatever I'm inheriting, like in Java, where you inherit from a base class, and then you just say, I override this functionality of the base class with this. And I'm not interested where exactly it lives. I know it lives in this type. So I 100% would like this term more, but it's like override would be beautiful.
What I mean, what about like override implementation or override? I don't know.
Yeah, I'm not stuck to the implements. Why I said implement or why I ended up with this term was that technically this here represents an interface. And from the terminology that you use is you implement an interface. For the lack of, I just saw override was already used, so I stuck with but I don't care about the term. If we think that override implementation is better, or override field, like we can experiment with these. I in general think it should be short.
I think the execution part also, like the query planning part,
Hmm.
could also mention that like, this field is owned by this set of subgraphs. And this field is also owned by uh, another set of subgraphs that, define the interface object, right? So then we have like two classes, and then within the spec, we would have to define like what happens. Like, do you pick the field that is, owned by the type, or do you feel, or do you like, or they are all the same, like what's the execution
When you have
effect?
implements on it.
Yeah, or like basically, let's say if we
So
don't do the implement, but we allow to define the fields, and it means kind of implicitly that those are like primary sources for, uh, for that field within that type, and not,
yeah,
the one that were inherited from the interface object.
exactly. It's like if you do this on this field, it's basically for the planner as if for chair um, this thing doesn't exist. Like you have to go to C or D in this case.
Yeah, I'm thinking like if we have to be explicit there or not. And let's say if we have to be explicit, then it's fine because then, we give user the control. But if we don't, then there might be a case where people just contribute a field, right? Uh, and then the query planner picks that field from the chair, right? But it was already within, like, say, subgraph that has the chair,
Yeah,
that has the tax rate, So
yeah,
there will be like extra call, let's say,
yeah.
and people would be like surprised. So I would be explicit in that case.
Yeah, that's why I also thought about an explicitness. It's like you have something that already works and is predictable. And now there shouldn't be an accidental, we introduce text rate and
Yeah.
suddenly we get 2 or 3 more hops,
Yes.
depending on the keys you have need to resolve, right?
Yes. I agree. It makes more sense. And also when you think about like Apollo Federation and, being like backwards compatible or whatever, uh, then, it's like a opt-in and not, oh, the
Yeah,
behavior is no different.
exactly. That was also mine thinking. The one thing I really overlooked was that we have also this shareable semantics here. And
Uh, and another point to try kind of to I think we've already accepted it, but in Schema A at the top, Michael, if could you add another interface underneath product? You can call it whatever you like, and
oh yeah,
it has one field which is tax rate, and it's not an
yeah,
entity or anything like that. Yeah, and then if you
this
could
one.
get rid of also the other two fields,
Which one? The here?
ID and name.
Yeah, yeah.
And then imagine, for example, chair here also wants to implement physical product, and we're not trying to override anything. So actually, we have to add tax rate, but we would add it with external to say we're satisfying the interface. This is also a valid case, right? Where in this case, we're not trying to. We just need to reference the field,
Mhm.
but we're still talking about a field that is contributed by an interface object elsewhere. Um,
Yeah,
it's just I'm just saying it's another case where you actually need to have that field in another graph.
yeah. That's a good case. I will add this example. Yeah, yeah, yeah. There's also one more case. Let me actually. And because there is, right, did I expect that? There is interface, this one, there's this one. Ah, yeah. Okay, I'm not sure about this one, but let's just copy this one. And we could also decide to forbid this one, right? Here we have product, which has a physical product. And then we have like whatever ebook here. And on source schema B, we are introducing text rate as an interface object. And then another subgraph C introduces a interface object for physical product, which is text rate, which is in the inheritance line. So we would fail that if it doesn't have implement or shareable on it. It's like a corner case, but
Oh God. So
so for all physical products,
so everything that inherits from everything that inherits physical product um would have their implementation of tax rate override. So you could actually have a set of things that still happen in Schema B and a set of things that are actually overridden. And yeah,
yeah,
this is di absolutely diabolical, Michael.
it is the case that exists. We could decide to say no, but there's also I just when I thought about this, there could be a thing where people want to categorize these things.
If someone gave me this graph, I would wonder who hurt them. But I mean, it's a valid case, right? Like it's conceivable.
Yeah, that's why I added it. But like we can still decide to say um, it's too much, and we preserve option value here and say okay, we allow it later, or we say this is good and we uh, put it in the initial spec.
I mean, but this example is also possible where physical product and product do not have any overlap, so they don't implement each other.
Yeah.
Um, and only the concrete type is implementing both.
Yeah,
This
if they don't implement each other, then this wouldn't need to implement. Oh,
um
but then we are in a different.
oh I see no I see what you're saying. But then it gets weird, right?
Yeah, it gets weird.
Because does this override the other interface objects even though they're not
And
connected themselves?
yeah, if it's not connected, I would say we would have to force shareable here, right? If there were this,
Because how I think about this, and maybe it's the wrong way to think about this, but when I see something like Schema C and I see an interface object in there, I think that this is just kind of like sugar for basically having the interface in that graph and then the unfolded types all in that schema. This is how I think about it. So for me, if you have at implements there, it's basically just saying everything in here inherits that directive and this field with that directive tag. So it was as if you're writing chair with tax rate and then at implements in, which would then chair having that in that graph would then correspond to schema B. Do you know what I mean?
mhm.
Like this is how I think about it. I'm not sure it's the right way to think about it, but this is how I think about interface objects.
Yeah,
So
go ahead.
no, that's what I'm saying. So I actually don't know how it should behave if you had at implement on tax rate there without any without physical product and product being related themselves, only the implementation
Yeah,
types being related somehow.
like in this case, for instance, like okay, IDs are keys, so they are shareable. But I would say if they're not related, they need to be shareable. And then you cannot like
Yeah,
if they
no,
are not,
absolutely need to be shareable, of course, yeah.
and then you have to have like there's no direction that you can give in this case because they are just two alternatives in this case, right? We have no inheritance, so there's no direction from a type graph. So these are shareable and they could be they could be used whatever by the planner.
Um, but for example, if you were to put at implements there on where your cursor is, so again,
I would fail this because there is nothing to implement. Because you have no direction here, right? You there is nothing in your type hierarchy that you actually could implement. So I would
yeah,
actually have a composition error in this case.
I guess I mean I think the way you describe it makes sense, but uh, the reason because adding a directive on an interface object field is doing two things, right? It's trying to it's being able to have the children or the implementation types inherit that directive, but in this case, implement um, specifically means that the thing that the 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 parent type of the directive must have some kind of interface relationship that it's overriding, in which case this doesn't. So we shouldn't allow it in the first place, even if we wanted to pass it to the children for whatever reason, I suppose. So I
Mm.
guess the simple answer is that you wouldn't be allowed to put this because there is no interface
Yeah.
relationship.
Until you do this, right? And then it's suddenly there is an inheritance relationship.
Yeah,
And now we have a direction from this is actually the one that should be applied, and this is the one that overrides this one.
yeah.
In the case both are implemented.
Okay, just to play devil's advocate, if you had a third interface and a third and another graph, and then that one also had implement, what happens?
Oh, in
So
this
you,
case, do you have to be shareable? So these are both implement. These are now because they are shareable implements. Like they are allowed to be chosen either one.
so you can over, so you could you, but how
You
does that
can
make sense? How can you
if
override
you
from
take
both?
this away, this would get a composition error because like they are not shareable. Like this one is shareable, but this one not. And now the planner doesn't know if that was intentional to add this thing in here.
But which implement wins?
Doesn't matter. Like because
So
they are on the same hierarchy.
no, I'm saying no. So
Oh,
imagine
oh,
subgraph
you have
D.
a physical product
Yeah,
too, right?
and then in schema A you've got a third, like it's in physical product implements product and product.
Here,
Yeah.
interface.
So this would be physical product two, implements product and physical product two. Like I know this is getting crazy, but like just to
Does it implement product as well?
it implements the other two.
Oh, I get where you're going. Okay, okay,
Yeah.
okay, okay. Yeah, yeah. In this case, we would be shareable.
But wait, physical product two also needs to implement
Yeah, it implements.
physical product
Oh,
on line 11.
yeah, it implements, but they are because they are on the same level. They are in the they are shareable, so independently could be chosen.
On line 11, could you add and physical product?
Line 11. Ah, here.
Yes.
Okay, and then they are directionally
So
again.
now you've got this three-way relationship.
Yeah.
Um, So if you had now implement on as you do in Schema D, which one wins, Schema C's implement or Schema D's implement?
In this case, schema
Or is
D.
it just an error? Like
Schema
what?
no, schema D wins in this case, or because it's hierarchically this is the deepest, because this one implements both, and like there's a direction in it, right?
So the closest one wins.
Yeah, this one, the most outer one. GraphQL just forces you to implement both. In traditional type systems, this is what you would do, right?
Yeah.
And that then makes sense because now you have a direction, because if you clean this up, that what would be the inheritance direction. We just in GraphQL SDL decided in the spec to do this because SDL is often used in snapshots. And when you remove a thing out of the hierarchy, then the idea was that you see that better in a snapshot, the effect that it has. But there is actually still this direction in there.
Right. But it does mean that in Schema C, line 34, this is completely redundant because it would never because we've got something closer as in physical product
Yeah.
2.
Yeah, but you could still implement a product. You could still
Oh,
implement something of
another
this.
type could have it, but not
Yeah,
all of them. No, wait.
yeah,
No,
yeah.
no, it would have to have all of them, right?
This
Oh
one
no, it
could
could
be.
have just physical product and
Yeah,
not
this
product
one
2.
could just have physical product, and
Okay,
then
yeah,
it would
okay,
choose
okay.
C.
Yeah.
So it actually makes sense. I
Yeah.
don't know if it makes sense to build such deep inherit. Like at some point, will become very complicated to like if you have 4 or 5 levels, then it's
Yeah, there might be there'll be an intersection, but not necessarily
yeah.
a one-to-one match of implementation types, right? So yeah, I guess you have
Yeah.
yeah. Okay.
Yeah, I write a bit about that's one thing I also started writing about the whole runtime behaviors, because that was missing from the spec so far, and I will add also for this a bit the cases that we discussed today as a runtime behavior, so it's easier to reason about.
Camel looks so done with this conversation about interface objects.
It's just Thursday, you know.
Yeah, but like I found that um, these were a lot of the issues people had on GitHub that they filed for Apollo Federation, where they said it's not flexible enough on this area. Okay. Yeah, so I'm gonna rewrite this, and then I bring it up next week. We can go over it, and I think that is a real improvement over what we have in Federation today, and what we can then implement.
Yeah, I mean interface object today is spit and sticks basically.
Yeah,
Holding it
I
together.
think they needed a solution for this problem, and they just threw something at it.
Yeah.
But I also like I experimented with a couple of ideas, but in the end, I think just improving what we have is better for if you want to support both.
Yeah.
Yeah, and that's from my side. Like there is just as a reminder, there is a couple of issues open, pull requests open, where I try to make the text in some cases better, or add new rules. If you find something, just open a pull request uh, and add it, and we can discuss it also.
Cool.
Awesome. Check the chat. Federation playground. Oh, nice. This does the composition in place, Karen? Oh, I didn't. I'm not
Sorry.
sharing anymore.
Oh,
Sorry.
the playground. Yeah, it's like I used it to like, you know, I basically did it. So when we have like internal discussions about, this or that or like bug reproduction or whatever, you like
Yeah,
place their subgraphs, you click share, and then we like, can sync.
I like it.
Yeah, it's like easier. Usually you have a setup when you just run it all the time and write files and all of that. And I did it so
Yeah.
many times for like 2 years. Then I decided to like, spend some tokens and build something.
Next meeting we're gonna use that.
How, when did you release this?
Oh, it's like internal thing. It's not even like released or anything. It's just like
Okay,
up.
when did it become a when you know what I mean? When did this happen?
Uh, I don't know, like a few months ago.
Okay. No, it's kind of cool.
It would be nice to include like
Yeah,
like basically I wanted to have like a playground when you can, check if things works. Uh, yeah, like for example, the discussion we had with the interfaces and so on.
yeah.
Uh, you can just like type there, click, and then you get the feedback. So it would be nice to have that also for the Apollo composition.
Can I make a feature request for your non-release thing? If you could have a share link, then you can share people.
Oh, it is there. Like
Oh,
if
it's
you
already
can,
there.
yeah, yeah, yeah. It's just that there's no collaboration, so you don't have like, live editing and so on. But if you click share, then it keeps the state. So if you share it with somebody through the link, the
The
person will
super
get
graph.
the share.
This one? Is this a share button?
Uh,
No,
it's
copy. Yes. Yeah.
it's this one that says
There. That
yeah.
says share. Sorry.
It's the button
So,
that
so,
says
so
share. To be fair, I didn't see it either.
I
because
mean it's AI did the work, so
Yeah.
yeah, in iPhone you
Can you
have
make
this
it
share
blink
button.
so then everyone can see it like this?
Uh,
yeah, it's
that's
just
good.
like easier to collaborate on things. So like quickly check if it's a bug or not, this kind of stuff.
We have
What's with the formatting on the supergraph?
Oh, it's just like we this is what we produce pretty much.
No, no, I know, but like there's like a bunch of like new lines and
Yeah, this is what we produce. It's like it's a server stuff that like, you sometimes read. And if it's like, couple of new lines, like
yeah, they just didn't polish.
yeah.
no, but no, but this is a useful tool for sure.
Yeah, next discussion we're gonna use it.
Yeah, the other and I think like it's much harder problem to solve, but if you could then, or maybe it's already possible, if we could then look at query plans based on
Yeah, what actually would
hypothetical
be
operations.
cool.
Oh,
Can
yeah,
you also use the Apollo composition?
yeah, I could add it. I mean, it's like for like internal use cases, pretty much. So our composition, but we could have something that is like, includes like you can pick
Yeah,
the, I don't know, like
composer.
vendor or whatever. Yeah.
Yeah. Yeah, no, just if you want to have the absolute Apollo behavior, it's always good to check. And then
Michael doesn't just have.
Oh, at this
yeah,
stage, there's
would be
nobody.
cool. Yeah,
It's just code.
awesome. Awesome. Okay, then this is from my side. Does anybody else have something? Okay. Overbright. What did you want to use?
Yeah, I'm just kidding. Yeah. It's like if you don't want to have conflicts, you just name it differently.
You know it would fuck everyone.
Yes. Even like the Apollo's like compose directive, like the directive that like, passes the directive to the final schema. It's like I
Yeah.
never know if it's like compose directive or like composed, like ED. You know what I mean? Like I never know.
Awesome. Okay. See you in 2 weeks.
Thanks. See you. Bye bye.